A couple of restoration caveats, general ones when you're using these methods. Speed is key. How quickly can you actually restore this backup that you've taken? You're going to want to have a nice fast path to get it back onto your new host or a new VM. You don't want your downtime to be exacerbated by the fact that you've got all the data, you've got everything backed up the way you wanted, but you just can't get it where it needs to go quickly enough. Test regularly. Make sure that there's not something going wrong with your backup process, introducing maybe corruption into those backups. I did see a case recently where the use of, I believe it was the PGSI compression program, was actually introducing some corruption into the archived versions of the backups. So the pre-archived versions, before compression was applied, that's what people were testing on, and those were fine. But when they needed to go back a bit further into, say, yesterday's backup and use that for a restore, the data was coming out garbled because the compression program they were using actually had a little bit of a bug. So test regularly, test often, test the full process end to end, and make sure that your restore actually works. And then the final one that I'm going to mention is a much more specific caveat. That's EBS snapshot restores in Amazon. When you attempt to attach an EBS snapshot to a running instance with the intention to restore, there's a little bit of sort of magic that happens there. What's going to happen is you're going to have your normal, relatively local EBS volume. It's still over the network, but it's going to hopefully be close enough to your actual running VM. So here's your VM. Normally you can expect your EBS volume to be somewhere here, so this will be local in quotes, be relatively local EBS volume. That's how a normal EBS volume would actually work. What you're actually getting if you do this restore is it's actually going to the longer term storage back here where the snapshots are stored. And as you start to access the blocks on this EBS volume, they'll be lazily loaded. This is a very simplified version of this. In fact, it may be completely incorrect. This is how I think of it myself. I haven't actually talked to anyone in Amazon to completely verify this. However, I do know that once you've restored a snapshot, you're going to lazily load those blocks from the remote storage. So this can be quite slow. So if you're going to be doing that lazily loaded blocks, it can be necessary to take some extra steps to make sure that that slowness is not passed on to your users. And we've already covered a couple of the techniques you can use to get around this. It was covered in our preheating module. And there's a couple of different approaches that we covered there. The first one was the touch command, where you read the various data files for a particular collection and its indexes into the file system cache. You can do a targeted find explain. And again, that will be paging the various different pieces of data that you're going to touch with your query into memory, but also because of this lazy loading, it will actually be fetching it and storing it more locally. And then the final way to do this is use something like the DD program. That's included with most Linux distributions. You can just use that to sort of scan through the whole thing. You can pipe the output to dev null, that kind of thing. There's plenty of guides on how to do this, and particularly if you're not sure where, you can just use DD to scan through the whole thing. That will fetch all of the various and touch all of the various blocks. They'll then be fetched, and you'll incur less of a performance penalty then when you're actually using them in production. So that's just one of those little caveats to be aware of.